Hello and welcome to the EEPROM 9. Those of you who have been long with me long enough to remember, which is about 6 people, will remember the Nixie driving Nixies video. There'll be a link to it if I remember to put it down there in the linky thingy mabob. But this is basically an extension on that by using the driver chip, which is a Russian chip, and it's got a Russian part number on, but it's basically equivalent to the 74, what is it, 741 or something, something like that. So we have it configured up, wired up to the tube, available resistor, although the chip seems to be doing the current limiting, dip switches, which does your which gives you binary 1, binary 2, binary 4, binary 8. And now we should count up in binary on it. But first, let's give it a bit of shadow so we can see it a bit better. There we go. Avoid the light glares too much. So, 1. Good, you can actually see it on the camera. 2, 3, 4, 5. You'll notice the 5 is actually an upside down too. 6, 7, 8, 9. And the 9 is also an upside down 6. But yeah, as I can see, you can see it there. The orange glow is more bright and not so representative of what it actually is. And that's basically it. We can now get it to count because this particular chip takes BCD input. And since most of you know the binary, you know that's 1, that's 2, that's 4, that's 8. So we've got a max of up to 15. But if you try and do something like 15, which will be the Moulon, the chip is designed to blank the Nixie tube, and the camera flash just charges it up till all the segments, till the numbers light inside. And of course we can get numbers, so yeah, to play with this you'll need to know binary. But I'm thinking of building this up into a little self-contained unit, run it off battery, and then you can take it into uni. Just have it as a cool little toy to sit there and play with when you're bored. I like that, I like little toys, especially cool ones like this. Now I'm not really going to go into how Nixie tubes work because I can't be bothered, people on the internet can explain it far better than I. I'm not always the best at explaining things. But yeah, you could link that to a microprocessor, 5V TTL, because that's what that chip's designed to do, to convert over 100 volts from this. For this, that this can take, so the rest of the circuit can be happy. The rest can be all 5V and happily control it. My frequency counter is on a similar prospect, that's over here out of sight at the moment. But for now, that is all. Thanks for watching, and remember, 3 is not a magic number. I'll make a cock out of these or something like that at some point. Thanks for watching. The bleed resistor's working as it should, because if you notice it's gotten rather dim. I've got it built onto a circuit board. Yay! And there's a camera flash unit which is driving it. 2 power inputs, 5V and a 1.5V. Sorted. And of course I soldered a bleed resistor across the big ass cat too, so discharges safely and I don't have to do that shorting which involves in a small explosion. It is kind of fun, but it's also kind of scary at the same time. Then that just controls the current to the tube so it doesn't get damaged. Now to get it into this case, which is precisely why I've shut it off so the cap can discharge and I can get it in that nice case. Thanks for watching. And so it's to somewhat stage of completion, and once again my electronics design is perfectly fine and decent, but my case design is something to be desired, so I don't think it'll be in this case for particularly long before I rip it out and find something better to put it in, or go the whole electrical tape it over route. But let's show you it running. So we'll first turn on the logic, which is this switch here. Yes, I haven't actually mounted them in the case yet. At this rate, I'm not going to do it today. I've got too much other stuff to do for my interview. Turn it on and give it a few moments and it will eventually decide to light. And it works, there we go, it's lighting up now, it's got decent brightness, camera flash unit works off a single AA, 4.5 volts does the rest, and voila. As you can see, the 0 segment is lighting up and we can actually make it a bit brighter. There we go, so we've got it a bit brighter. So let's show you a few things of what it does. I'm not going to go for a full demo of it because I already have. But there's A. This one's going to be 4 if I get the finger position right. 2. And of course the most difficult switch to reach, 1. And as you can see, it works. Now this was just built as a fun bit of pointless project, but now that I've actually built it, something has come to mind. With my level of skill, I could actually build a Nixie watch quite easily, because we've already got our HV power supply, they're readily available, and I've got a really small one which is somewhere here. Take off the flash, remount the cap across the board, sorted. That's your HV power supply, compact and nice, and you can mount it in the back with its power supply battery. Then you just got the logic. Wow, look at that, that's tiny, that's your logic, that's tiny, you could easily mount that on a wrist mount. Then it's just sorting. The only real problem is finding components which are power efficient enough. And the focus isn't working, grrr. There we go. It's finding components which are power efficient enough for the design. Other than that, you're alright. So, for now, thanks for watching. Is that dimming because of the thing? I think the battery may be suffering a bit actually. Anyway. No, it's charging. Who knows? Anyway. The point is, it works. Oh, I get how this works. Yeah, I'm working out how it works. Depending on the resistance you put there will depend on not only the brightness there, but also other factors that I can't be bothered to explain. But yeah, this proves that a Nixie watch is perfectly within the realm of possibility from me at this current time. I just need to do the research on what processor to use, because power consumption, of course, is very important when you're running off batteries. But for now, thanks for watching. You can consider this the beginning of me designing my own Nixie watch, which will probably be another bloody 7-year or longer project. Typical. Thanks for watching.